Eric Darling here with Darling Data, and so every once in a while I get a user submitted question that I would love to answer in a longer format than just something on office hours. So that's what we're doing today. I've decided to postpone by one day another Learn T-SQL video. I do apologize if this is heart-wrenching for you, but we're gonna learn something different about SQL Server. The question someone asked was, when I compress an index, is it just the index key columns that are compressed, or is it the included columns that are also compressed? And I said, you know what? I want to answer this. I want to show my work on this. So that's what we're going to do. If you like this sort of content and you would like to spend more time with me in some way, shape, or form, there are all sorts of links down in the video description where you can find ways to spend more time with me. And I would highly suggest you start clicking those before I decide to start spending time with someone else. Okay, so you do have to buy my affection. If you would like to do the bare minimum to support this channel, of course, you can like, subscribe, or tell a friend if you have any friends. And I realize that you're a database person, and that might not be the case. But if you do have a friend that is not a pillow, tell them about the channel. Live and in person, where I will prove that I am not a pillow. You can join me in Dallas, September 15th and 16th, in Utrecht, the Netherlands, October 1st and 2nd, as part of the Pass On Tour mini events. You can also catch me live and in person in Seattle, Washington, for the big Past Data Community Summit, November 17th to 21st, where I have exactly 2 days of T-SQL pre-cons alongside Kendra Little, where we will teach you more than you ever wanted to know about T-SQL in a very short amount of time. So I highly suggest you show up to both of those days so that you are not left flat-footed in life, because you are a database person. Anyway, let's go talk about compression. We have to go to SSMS for this, don't we? Yes, we do. All right. So what we're going to do is create some indexes. And you might note from some of this that I am creating very descriptive index names here. I don't often create index names this descriptive, but in this case, I wanted it to be very clear what we were looking at. So what this index name indicates is that we have a key column on reputation, no includes, and no compression. This one will be an index keyed on reputation with no included columns plus page compression. And I do completely recommend page compression over row compression. And then we have this index with a key on reputation, including display name with no compression, and then finally an index that will be keyed on reputation, include display name, and have page compression applied. So let's create these indexes. They create relatively quickly, so I'm not too concerned about wasting your time here. And what we're going to use in order to look at the sizes of these indexes is a little helper view that I have in my GitHub repo. If you go to code.ericdarling.com, remember that's Eric with a K, like the Viking, you will be able to find in a little folder called helper functions, some functions that I've written, I use in some of my demos and presentations to just give me quick results back, where like a whole store procedure would just be unnecessary to show these things. We're going to look at the index sizes on the table users for the indexes that I created here. We actually don't need this one. This is left over from something else I was looking at. We just need this. That was silly. Why do I have that? That's ridiculous. All right. So if we look over here, let's zoom in this way. All of these indexes have the same number of rows, but they have very, very different in-use page counts, don't they? They also have very, very different in-row pages MB, don't they? So the first index in here is the clustered primary key on the of the table. Users is a clustered table, right? So we have a clustered index on our table. So we don't really need to think about this one that much. The ones that we want to think about are in here. So these very descriptive names are finally coming into fruition, and they are living up to their maximum potential. So for the index that has a key on reputation and includes display name with no compression, it is 89 megs. almost 89.5 megs. For the index that is keyed on reputation, includes display name, and has page compression, we are down to 49 megs. So we chopped about 40 megs of space off of this index just by adding page compression. Now, this is where things get interesting. The index that is just on the reputation column with no compression, well, that's, if you look at that, like with the display name column in there, these are pretty close, right? They're about 15 megs apart. And this is just like an uncompressed integer column, right? 34 megs. Compressed integer, including an varchar 40 column, is about 50 megs. So they're like, so we do fully compress everything in the index. And now if we look at this one finally down here on reputation, no includes but has page compression, you see there's a pretty big difference here, right? So I think we can conclude from this minimalist test that SQL Server will not just compress the key columns, but will compress all of the pages in the index, leading to maximum compression potential here. So this is all of the leaf level pages, which become, slightly less dense when we start including things in the index. Those are also compressed as well. So to the anonymous user who submitted it, I forced everyone who asked a question for office hours to remain anonymous. I don't want to know who asked these things. God help me. Thank you. I appreciate your interest in page compression. That shows me that you have a very keen eye when you watch my videos and you see me creating all my indexes with page compression, because I do love page compression. Thank you for submitting that question. And to everyone else, thank you for watching. I hope you enjoyed yourselves. I hope you learned something. And I will see you in the next video, which, since I believe this is Friday, that will be office hours on Monday. So we have that going for us, don't we? All right. Thank you for watching.